हेलो हेलो हेलो। Good evening, everyone. Welcome to today's class. I hope I'm audible. My screen is visible to all of you. Yeah. So today, till the last class, we were dealing with uh, uh, the leaf scale energy balance, where we learned about what are the different components of energy balance, the radiation component, sensible heat, and the latent heat, and how is leaf energy balance represented. And this leaf energy balance is primarily important to obtain the leaf temperature, which is a very important parameter as far as plants are concerned. Um, so in today's class, what I'll be doing is, since I've got a couple of more classes available, I mean, I think I completed a good enough portions concerning C3. I'm not sure if I'll be taking C4 or not, but if I have time, I'll be doing that. Otherwise, I thought I'll introduce all of you to this R software so that you can make use of this BioCro module. I mean, even if I can't, I've already explained a bit about using BioCro. I think many of you are not very familiar with using R, and probably a lot of you are also not very familiar with the coding part. So today and maybe for a couple of classes, I will we can work on R to know how to use basic functions of R, and I hope all of you have the R software installed, R program installed in your system so that you can uh, do it along with me. And if there's any error, you can post it and I can help you with that then and there. And that will be the most effective utilization way you can utilize these sessions on R. Um, okay. So I had given a brief introduction to R, but then let's go back to it again. So R is a programming language that is majorly used for statistical and data analysis. And when I asked you to install, how many of you have R in your system? I mean, I think there are three of you here. I hope all of you have R in your system. Did you have any difficulty installing it? Okay, good. So that's great. So when I asked all of you to install R, I had told you to install R tools along with R Studio. So R tools is what is actually installing this programming language in your local system, in your computers. And R Studio is a graphical interface that makes the usage of this R program easier. So usually we see that whenever we are running some codes in some programming language like C++ or Python, we have to make use of a command prompt window where we are typing in open this, close this, save this, exit this. You have to type in commands. There's no click and selecting this tab and clicking options and all available. So with our tools, that is what is possible. You can make use of certain commands in the command prompt window and then run codes or do whatever it is that you require to do using the R program. But the added advantage is R Studio is a graphical interface that helps you to do all of these with the help of user-friendly tabs and options which you can click, as well as you can write the code and run it. So both of it is uh, useful. So in that case, this R Studio is very user friendly. So R contains this R console. R scripts and the R graphical device. The R console is where you can type your command and receive the results. R scripts are those codes that you create so that you can run it all together and save it so that you can use it during a later time. And R Studio is this graphical device that is used for displaying, editing, and saving graphical outputs. So this is the R Studio environment, the graphical interface. And if you see here, it has got four windows to it. The first one is the window where the editor window. The second one is the console. The third one is the window where you get the environment and the history and everything. And the fourth one is the window where you can obtain the plot results, where you can access documents and everything. So the source pane, that which is the editor pane, over here is where you write your codes, and this it is in this part of the window that you write your codes, and you can save it, and also you can run the codes there. And when you run the codes, you will get the results over here. Will be shown over here, and whatever you do over here, the result of this can be seen in this console window. So if you are actually running a line in this window and you get an error, the error will be shown over here. Now, whatever results are stored as some kind of data structure or stored in some kind of form is what you can see in this third part of the window. So here, this is called the environment window, and you can also see there is a tab called history. So history is where you can access what was being done in here earlier. And source pane, this is called the source pane or the editor pane. It is where you write your R code, and you can create a new script for each type of code. Now you want a code for doing arithmetical operation. You want a code to do some statistics. So you can write a new code there. So this is all possible in the editor pane. And then so much of editing can be done, the highlighting, code completion, indentation, and everything. The console pane is where you directly interact with R. So basically, if whatever you're doing in the source pane is actually can actually be done in the console by giving some commands over there. So if you give some commands over there, you can actually do whatever you're doing in the editor pane. And so console is nothing but something like the command prompt window. Now, when you're doing Python, there also you'll have a console where you can give commands and write some code. So I will write some commands to get some work done with regard to the code. Then environment pane is where a lot of whatever you have done will be available. If you have read a data, that data will be available there. If you're going to write a data, that data will be available of there. If you save a data, that data will be available, and that all of those data you can see in this environment pane, which is the third window in the right top corner. And the output pane is where you get plots, where you can get help documents and all such things. So all of you must have installed installed R tools in RStudio, hopefully. So let's move on to working with this R. So I had said that whenever we open R, the first thing that we do is to obtain the working directory where you are actually working, and then set the directory to a place where you want to save the file. So first I'll do new file. Now new file, is my screen visible enough so that you can follow it? Mm, yeah, I think this is big enough. Okay, great. So if you see here, I'm going to take a new, I want to write a new code. And that code is what we are going to be write a script where we are going to write all the codes that we are going to use in today's class. So I'll take a new file and then R script, and a new file will be created over here. Before that, what I want to do is see where this file is going to be saved, or where is this program running as of now. And for that, we will be using this command get working directory, that is getwd, and a parenthesis. And so we will get the working directory in which we are in right now. But I don't want this working directory. I want whatever I'm going to save into some other in another folder. So what I'll do is I'll go to the session tab over here, set working directory, and choose a directory of my choice. And for that, I'll go to one folder where I'm saving all this code, and I'll open that directory. So here you can see whatever we did right now, we can do it using the set working directory command also. There's a command called set working directory, setwd, and inside the bracket, if you give the file path, the address of uh, this file or the folder, you can, if you put it inside here, you will be able to set the working directory. Now, a good thing about this was a very quick step because you know where you want to save your file. The same thing can be done, you know, right now I'm working, say suppose we go back to the old working directory. I mean, initially where it was, we'll go back there. Let me close this. So here I got my working directory as C users Dell documents. Now I want to set it to another folder. In that case, what I'm going to do is I put something like a dot, two dot, and then forward slash. And then when I press tab, I see a lot of folders over here. So what this two dot is doing is that the two dot is taking us to the folder which is just behind this documents folder. So if I press two dot, I will be taken into this folder Dell. Now if I press two dot again and a forward slash, and press tab, you will see all of this is folders inside the users tab. Now, if I press two dot and forward slash again, you will see that all of this is the files in my C drive. So this is what a two dot will do. Now, if you want to, if you want to work within the same directory that you're using, like I set my working directory to the directory that I'm interested in, which is BioCro codes. And then I want to access a file within this directory. Then for that, what you do is you only put one dot and a forward slash. So two dot is actually taking you back to the previous folder, then whichever folder that you are in, and the one dot will help you access those files within the folder which you have set as the working directory. So now to a one dot slash, and if I press a tab, nothing comes. Okay, that is because nothing is there inside that by, yeah. So if you see two dots, I set my working directory to BioCro codes, but since there is no file inside that, there is files. There is no folder inside that, I will not be able to access. Now here what I'm doing is two dot is there. There are some documents in the folder, this folder where in this ISSSTA folder. So those folders are all of this. When I press tab, I can access all of these folders. So two dot is to take you to the previous folder uh, than the folder that you're currently working in. And one dot is to access all those files which is available in the current working directory, whichever working directory that you're set to. Now, yeah, okay. So that is getting working directory and setting working directory. Now, this console, like I said, this console is one place where you can do a lot of, you know, activity, you can do a lot of things just as rough work over there. So suppose you want you want to add something, you can just do 5 plus 3 and you get the answer. You want to do some simple arithmetical calculation and you will get the answer. So all of these things can be done in the console. Now, if you see, this 1 over here is giving us the index of this result. So index is at what position is this result stored in. Now, as of now, the result is not stored anywhere. We just did an arithmetical calculation. But if we save this in a file or something, the first element of inside that file, or first value inside that file, will be this one. So this value in the bracket is giving you the index of that result that you have just now found out. Now, like I said, let's do some basic operations in R. I hope everyone is clear until now. So now what we're going to do is we're just going to see how to assign a variable, how to do some basic arithmetical operations in R and stuff like that. So this way of writing to a hash and writing something is called commenting. So this line, whichever line comes in green color, will not be it's not it is not a code. It is just one line that you're writing, just to, like a heading, or just to indicate what you're going to do, so that you can get ideas of what is the code just below that you're typing. So I'm going to assign variables, assigning variables. So my intention is to do some arithmetical operations. So first I will assign a variable to to a variable x. And when you assign a variable, you use the uh, the lesser than sign and the hyphen, and you can assign a number to it. You can also do a variable, an alphabet or a variable name equal to, and assign a number or whatever it is you require to do so. So while doing this, this is the way you assign something to a variable. Um, this less than two sign and this hyphen, and otherwise you can use equal to. But this is the most common way people use generally, more than equal to. So now what we did is we assigned the value of 5 to this variable x and assigned the value of 10 to this variable y. Now we're going to do some basic arithmetical calculations with this. Basic arithmetical calculations. So first I want to find the sum. So I'll write sum, or sum of finding sum. Find sum as one variable x plus y. And then I enter, oh, sorry, I didn't run this. So the one important thing is you need to run these two lines. Only then will the R understand that this x is equal to 5 and y is equal to 10. So now I ran this too. You can see that in the environment you got x is equal to 5 and y is equal to 10. Now if I run this line 7, you can see that I got a variable with the sum of these two values, which is 50. Now, similarly, I can do find product, which is nothing but x into y, and run it. So, if when you're running a line, you can use this run tab on the top over here, or you can use the short key CTRL plus enter. So here, when I'm finding the product, I get the product value over here. Then find quotient, and I do x divided by y, and I get the quotient, and find what's that difference, and I can do y, y x minus y, and I get minus 5. So these are all very simple arithmetical calculations you can use: plus, multiplication, division, and subtraction. Next, Okay. Now, in order to print these results, now I don't know. I want to find out what the value of x. Now, uh, suppose in a very long code, you don't know what x and y is. You'll have like 10, 20 variables that are assigned. So in order to find what it is, you will just print x, and when you press enter here, the you will get the solution. Similarly, if you print find sum, you will get the value of the sum over here. So this is when we need to, I mean, all of these will be available here, but then when there are like 10, 20, 30 objects in this window, you cannot keep scrolling and looking for each of it. So for a simple this one, you will just print what is the value, or what is the what is the value to the variable assigned. So that is how you do printing. Now, so assigning variables we did some basic arithmetic calculations. Now we move on to data. So every programming languages data or whatever information is stored in different types of form. So if when we are storing numbers, it will be numeric. When we are storing alphabetical, anything that is alphabetical related. Now, programming doesn't have any vocabulary, so they will just store the characters, the letters in it, and it does not hold any meaning to it. Only the only meaning it understands that it is not a number, it is a character. And then there is also another data type called the logical. That is, if something is equal to 2, then this is true. Or if something is equal to 5, this is false. So the true and false, which is called the logical data type. So here, if you see, I'm going to assign a variable um, A as some name, and B as a number. And you have to see, whenever you are assigning a character variable, you have to always put it within double quotes. Then only it will recognize it as a character. Then C as a logical expression. Now I don't know what all these are called in this one. I'll run all these three, and then I want to know what kind of variable have I assigned. So for that, I will do something called class. You can see my console over here. Class A. What is the class of A? And then you see that it gives it's a character. So since it is coming within double quotes, we see that the R recognizes A as a character. Now another way you can find what kind of data type variable has is by using the command type of. And within type of, if you uh, put the variable name and enter, we get it as something called double. Now let me start with class. So that will be more easy. So if class is here and you put in B, you get numeric. So we know a variable is a numerical value. And if you see class C, you get it as a logical value over here. I hope you can see the console. That is where I'm trying to find out what all these variables are. So A, B, C, by using this command class and putting the variable within the parenthesis, you can understand what kind of a data type it is, whether it is a numerical data or a character data or a logical data. Okay. Now, I talked about basic operations in R. Now, when operations are conducted in R, it follows this rule called PEMDAS. PEMDAS is nothing but like how we have learned the BODMAS rule. This is PEMDAS is where R will first, when there is an arithmetical expression like this, R will first consider the values inside the parenthesis first. After that, it will consider the exponent values, this one. Then it will consider the values that needs to be multiplied. Then it will consider the values that need to be divided. After that, addition and subtraction. So this is how R, this is a sequence in this. R will analyze this one line and then um, sequentially do the calculation. First, it will recognize parenthesis, which is 8 minus 3, 5 over here. Then exponential. So 5 obtained from here, 5 square, it will be 25. Then it will do the multiplication and division. So you get 25 over here. So 2 into 25 divided by 5, you will get 10 as the result. Then it will add 5 plus 10 minus 1, which will be 14. So this is how R this is a rule. PEMDAS is a rule that R uses for conducting arithmetical calculation. So we can do that over here. We see we are assigning arithmetical operation. We are assigning a variable result to this calculation. So when we run this, we get that we don't know what the result is. So what we'll do is we'll just print the result. We can go print result. And you see the result is equal to 14. Another way of obtaining the result is you just type in result and then you give enter. Then also you will get CTRL plus enter. Then also you will get 14. So are you guys able to do something in the something with R as I'm doing, or are you just following the lecture? Okay, good, great. So we saw how to assign variables. We saw how we can do some basic arithmetical calculations. We see that these are the character data types that R is able to recognize, and we also saw that how we can do some operations. Now this is a very simple operations. We can find the sum of 100 numbers or 200 numbers and any amount of work. And using code, the extent of analysis we can do is huge. Now, we looked at three kinds of data types in R: numeric, character, and logic. And we also saw that how we can know what kind of what kind of value it is. So what is the type of data that is being used by using this command called class into parenthesis and putting the variable name inside this. Now, I assign a variable Q as 3.14, and we know this is a decimal value. Now I want to make this into an integer. Now in order to do that, what I will do is I will assign a variable as dot integer Q and I will enter. Just a second. I'm going wrong. Okay. No, this is not possible. Okay, this is for decimal. Now earlier on I said when I did type of Q, we see okay, let's just W run and type of W. We see this word called double coming over here. Now what is that double? So, R is able to store numerical numbers as integers. It can also store numerical numbers in the form of floating point. This floating point is what they call as a double. Now, what is a floating point is, now if we say, if we want to store a number like 0.0002, it it will be converted into 2 into 10 to the power minus 6. Now, if you see what is type of 0.0002, you see it is double. So R makes the assigns this or recognizes this as a floating point or a double as it is called here, so that it is flexible enough to be converted into this form, into 2 into 10 to the power minus 6, or in this form. But if it is not a double, now suppose we don't want it to be a floating point. We don't want it to change from this 0.0002 form. So what we do is we assign a variable as dot integer, say 5. And then if you look at type of Q over here, now you see it is assigned as an integer. So if you want to assign a number as an integer and not as a floating point, now the same number if you if you just assign 5 over here, and if you do type of uh, Q, you will see it's double. But in this case, when we assigned it as an integer, the type of the data is coming as integer. But in case you don't assign it as a integer, it will always be stored. Any number will always be stored as a floating point, which where it can be for the ease of calculation, it can be modified according to what is required by the calculation. So this is something that you will get when you do type of for any numerical value. It will be assigned as a floating point or a double. So apart from numeric, integer, character, logical, these are the 4 basic data types. Now we can check what data type is by using the class command and the type of command. So we did that. Now, right now, what we were looking were at data type. Now, all these data types can be grouped into some form of object. That is, you can have a list where you have the number of cars, you have the names of the people who that car belongs to, you have the age of the people, you have the address of the people. So all of these are called objects, and you're using various data types, numerical data type, logical data type, character data types to form these objects. So there are various kinds of objects in that is available in R, and we'll go into some of these objects. So one very commonly used, a very important object is the vector format. So vector format is nothing but it is a one-dimensional array that can hold numerical data or character data or logical data. Now what you have to remember is vector is a format, one-dimensional. That is, you can give one column or one row. It is just a single line of data which can be either character, either number, or either logical. You cannot combine all of it together like that you find in a Excel sheet. So here this you see uh, we'll form some vectors like this. So again, I'm a vector is assigned by using this command C, just like how we were using the class of a class and type of this vector is assigned by the C. You put a bracket and then you fill in numbers that are separated by column. That will be a numerical vector. And if you're using a character vector, again, you have to put the name or whatever string that you have in double quotes and then separated by comma. Then if it is a logical vector, again true, true, false, false, how whatever it is, which comma, which is separated by comma. So here you see all these are just one data type. You cannot combine, you cannot do something like you cannot create a vector that is a number, then character, and what you can see here, class. If I type class D, I get it all as a character. So here, what you see is all of these are considered as character. This is not considered as a number. This vector is coming as a character vector. But again, if you look at class of A, it is numerical. Class of B, it is character, class of C, it is logical. So vector is something where you can only store one data type, either numerical, either a character type or either a logical type. So, and it is done by writing a C and within the parenthesis separating the number or character or the true or false with a comma. So that is one very important. It looks very simple, but it is a very important data type in R. Okay. The next vector type is sorry, the next data type is matrix. So matrix is nothing but it is a two-dimensional array. We all know what matrix is. We have a 3 into 2 matrix means we have 3 rows and 2 columns. A 3 into 3 matrix means 3 rows and 3 columns. So matrix is a two-dimensional array, again where each element has the same mode. Again, this is not something where you can mix up all of it together. You all, for this also you need only the same type of data type. If you need to create a matrix, you have to create it with a single form of database data type. So here, okay, one more thing I like to say over here is str.a. So let's see what happens when you see this. If you want to know what is the structure of this vector type, I'm again going back to the vector. If you want to know what is the structure of this data type, we can type in this commands str and then the variable name, and we see that it is a numerical vector with 7 numbers extending from 1 to 7 numbers, and the numbers are all of these. Now, if you do strb, you will get it is a character vector with 3 number of datas 1 to 3, and that is these are the values. So str will give us what is the content of that, what how many numbers of datas are there inside the variable and all such things. Now let's move to matrix. So matrix is again we know two-dimensional array. So we can create a matrix by we can create a matrix by using this command matrix. So what I've done here is I want a matrix with the numbers starting from 1 to 9 with a number of rows equal to 3 and the number of columns equal to 3. So in order to create a matrix, a random matrix, we can create a matrix with this command matrix. Just like how you used C for vector, for matrix you will use matrix with the first argument. Now this position of all these things that come before every comma is called the argument. So this is a function and whatever details that you give within the parenthesis is called an argument. So the first argument has to be what are the data that you intend to provide within the matrix, how many rows you want, how many columns you want. Now I had also earlier told if you don't know, suppose you just remember this command matrix, then you can just in the console do question mark matrix and you will see the help over here that comes with matrix. Matrix creates a matrix from the given set of values. As dot matrix is turning an argument into matrix. Is dot matrix is testing if the argument is a matrix. So here you see when you use this function matrix, first you have to give the data. This is the data that we are given. We can just write here for your clarity. Data is equal to 1 is to 9. 1 to 9. That is 1 colon 9 is starting from 1 and till 9. Then number of rows, number of columns, by row is equal to false. That and all is given over here. See, by row is logical. That is, if false, the matrix is filled by columns. Otherwise, the matrix is filled by rows. Dim name is an attribute for the matrix or a list of length 2 giving a row and column name respectively. Empty list is treated as null and a list of length 1 as row name. So all of these details are given in this post. As of now, we just want to know how to create a matrix. So if you run this, you get a matrix created, and if you print that, you see that we have a neat matrix that is created over here starting from 1 and ending to 9. Now if you see the speciality of these things in the square bracket, you see that The columns are named as square bracket, within that comma and 1, comma 2, comma 3. And here you see the rows are named in such a way that 1, comma 2, comma 3, comma. So what it means is when something comes within a square bracket, the first one is always indicating a row and the second one is always indicating the column. So if you want to read a column, you will always type a square bracket, that is whatever function or whatever command, square bracket, comma, the number of the column that you want. If you want to read a row, you will always put in the first the value before the column. So this is what this indicates, columns and rows. Now we want to read what is the first column. We don't say, suppose we don't have, we are creating a new matrix, matrix 2, and I want to create a matrix with some numbers that is of interest to me. So for that, I will be putting a vector as the data. The data is equal to C. I'm going to put 5, comma, 2, comma, 8, comma, minus 8, comma, minus 7, comma, 1. So now I've given 6 numbers. Now I want number of rows is equal to 2 and number of rows, number of columns. See, by the time you type itself, everything will come here. So, and you will see that it is belonging to this function matrix. So then that means the argument is supposed to be given as a argument of the matrix. So n column is equal to, I want 2 columns and 3 rows. And then I press enter. Now I don't know what the matrix is, and I want to know what is the data in the second column. So what I'll do is mat2 square bracket, comma, second column. You will see the data in the second column is 8 and minus 8. Now I want to know what is the data in the first row. So then square bracket 1, comma. And I see this is the data in the first row. Now I want to see what is the data in the first row and second column. Then this is the number. Now let's see if all these are true. You just do mat2 and enter. This is the matrix. Now I wanted the second column in matrix. 8 and 8 was the answer given. I want the first row in matrix. 5, 8 and minus 7. I want the first row and the second column. The value is 8. So this is how you will look into not only in matrix, for any data form or any data structure. If you want to look into the column and row, the first value that you give before the comma will be the row value, and after the comma will be the column value. And you always need to give the variable and put a square bracket to read the columns and rows. You can't be using parenthesis over there. So until now, is it easy to follow, or is there any errors or some difficulties you guys are facing? R does not have a string data type, so is it not possible to access individual characters? Yes, you can. Whatever is coming between the two double quotes is a string character. We use that string as in Python. Here we use the name character. So every character is a string only. Whatever comes between two the double quotes is a string. Okay. Now, the next data type that we will be using is, now here are some things, matrix operations that you can do with using R. If you want to know the row and column, that is what we just now looked at. Mat row column, what is the variable name? So if you want to find out the sum of the rows, you will do row sums and put the matrix inside. You will get the sum of the rows, column of the sums, transpose of the matrix, matrix multiplication. All of these can be done using these functions. So we learned about what vectors are, we learned about what matrices are. Array is nothing but it is a data structure that can hold multiple types of data types. Now, unlike vectors and matrices, array can hold any type of data. It can be a combination of numbers, or it can be a combination of numbers and characters and everything. So here again, let's create an array. So this is an array that I've created. So here I'm assigning the variable ARR to an array, just like how C is used in vector, matrix is used for matrices. Array, this function array is used. First argument is again the data. The second argument is the dimension of the array. So if the dimension of the array is in this, we give it in the form of a vector, where this is the row, this is the column, and this is the number of layers. That is, if you want the array data to be categorized into numbers, first with 3 rows, 2 columns, and then 2 sets of data like that. That is first one set and second set. You give this third vector over here in this argument, which will give you the layer of it. So let's just see how this array data looks like. Now, if you type it in here, print it here, you see that this is the form of the data array. See, we see that we have 2 columns. That is the 2 columns that we gave here, 3 rows, and 2 layers. That is 1 to 6 is formed in the first group, and in the second group you have 7 to 12. So this is how an array is created in R. So we looked at what vectors are, matrices are, arrays are. The next data type is the data frame, which is one of the most commonly used and most required kind of data structure. So a data frame is nothing but something like an Excel sheet or a CSV file. You have one column with serial numbers, another column with names, a third column with addresses. All of these will form a data frame. Now, if you want to create a data frame, you can do it in various ways. First, you can create a vector. Say, suppose I'm creating a vector A, which is the serial number, or let me just do this. Serial number, a vector C, 1, 2, 3. Then names, again a vector. Any then marks C 20, 20, 50. Now I created 3 vectors, one the serial number, another the names, another the marks, and then I ran it. Now I want to create a data frame, say DF, consisting of all these vectors. So what I'll do is I'll do data.frame. Serial number is the name of the column, is equal to serial number, the variable names is equal to names, marks is equal to marks. And when you run this and see how this is, we see that we get a data frame over here with serial number heading 1, 2, 3, names Annie, Matthew, Sheila, and the marks they have got. Now the same thing you can create in a different way also. You can create it directly like df2. data dot frame, say serial number is equal to vector 3, 3, no, 1, 2, 3, 4, comma, names. The same thing what we named as variables, you can do it out within this thing itself. A, B, C. So something that you need to remember is whenever you create a data frame, it has to have, if there are 3 columns and 3 rows, then a fourth column should also have rows. You cannot create a data frame with, 3 columns having 3 rows and a fourth column with two rows. So here you can again put some marks, 5, 4, 4, and then df2 you run it. There. I think, see, this is the error that we will get if you put different number of rows and columns. Here I put 4 numbers, but then names and marks are only 3. So in that case, if I run it, there will be an error saying that the differing number of rows are there. Now, if you run this thing, now you get it without any uh, error, and we see the same thing that we created earlier using variables and naming the variables within this, we will get in this form. So this is what is called as a data frame. Now let's see what is when we type class df, we get it as a data frame. In the same way, if you type what is class array, you get it as an array. Now class serial number. Sorry. You get it as a numeric data type. So that is what a data frame is. Now, in order to access data frame, so since data frame is a little bit important, we have now created a data frame df that is having serial number, names, and marks. Now, you want to exclusively access only the, say, one of the values or one of the columns in here. So, what you do is we type in df dollar. When you type in df dollar, you get the columns available in that data frame. So you want only the serial, you want to access only the values of the serial number or the names in that. And if you select names and type and enter over here, you can access only the names that are available in the column. Now, in order to access again, similar to the matrix, if you want to access the first row and the first column, you type this in within the bracket, the square bracket with a row number that you want to access and the column number that you want to access and enter. You will see that in the first row and the first column, the number is 1. Same like how you're accessing a matrix file. Then if you want to see what is the heading of the headings available in this data frame, then you can just do head and the data frame, and it will give you the first 5 numbers. Now, suppose the data frame is a very huge data frame. If you want to access what is the heading or what are the first few numbers available in the data frame, doing head will give you this, and doing tail will give you, again, this is not a very big data frame, so only 3 values there. Head and tail will give you what is the first 5 numbers in the data frame. Tail will give you the last 5 numbers in the data frame. Then again, yeah, structure we tried df. See, 3 observations of 3 variables. The serial number is it gives you the entire detail of all the columns and rows. What is a number? The serial number column is a numerical data type. The names column is a character data type. The marks column is a numerical data type. So if you do structure for anything of it, you get all of these information. Yeah. Now, in order to manipulate a data frame, now you want to add a new column or you want to remove a column. What you will do is you want to add. Now you want to add a column. Now we know that DF is having serial number, names, and marks. You want to add a new column. Then what you will do is DF2 dollar. I want to add past. This is a new column that I want to add. DF past is equal to yeah marks DF dollar marks greater than 3. Suppose this is 3, 2, this is 5. So I want to create a new column that has a data of people who have passed a test or whatever it is. So I create a column by adding the dollar sign and a name to that column with the condition that if the marks is greater than 3, then that person is passed. So I made something like this. Now, if I check DF over here, nothing is there. Okay, now this data is only DF2. Yeah, it is there. Okay, sorry, I did it in DF, not DF2. DF pass is equal to DF marks greater than 3. Now, if you open this, you will see that one more column is added with the heading passed and all those people who have passed. So, if you see, if Annie has scored more than 3, Matthew has scored more than 3, Sheila has scored more than 3, so all of them have passed. So, it is true, true, true over here. If you do the same thing for DF2, run it and see DF2 over here. And you see that, sorry, DF2, let me run this. And then this, and then DF2. We see that the one with 5 marks is passed, the one with 2 marks is false, and the one with 4 marks is passed. So this is how you will add a new column. Now suppose you don't want this passed column, then you will do DF2. You want to remove that passed column. DF2 passed is equal to null. No, you will just do this. You will to this column over here, you will just pass the command null. And then if you check the column over here, we see that that passed column has gone. So this is how you'll manipulate the data frame. There are a lot of other things also that you can use in data frame. Again, I think we'll do that when we are doing some exercises with BioPro. Now, the last data structure is the list. Again, just like data frames, a list is also a very important data object or a data structure. And just like how we create data frames, we can also create lists, say addresses. Addresses, a list of um, names is equal to C A So here I have created a list. Now you can see that the name one with one name, the age, the score, and if they have passed or not. Now the same thing, if I put enter over here, it will come down. So this will help you in beautifying the code a bit, and give it won't look so messy. So that is why I put enter after this comma, so that you can have it in a more orderly form. So here this list is consisting of one name, one age, some scores, and a logical. There is no order to the data. Now when you looked at data frame, if you have one column and a row with three elements, then you have to have that kind of elements for all the columns and all the rows. It cannot be haphazard. But in a list, you can just create any number of items without any order. So if I run this, and if I check what is this, my list, then you see that I have a list with first element, one element as a name, one element as a number, one element as code, and one element as a logical operator. So these vectors, matrix, array, lists, data frames are all what you call as an object. That is, you're working with a function that will recognize a bunch of data as a list or as a table or as a single row or as a number of rows and columns, all of these. So any data that is involved with any data that you need to work with should be either in any of these forms, and all of these are called objects. So vector is an object, matrix is an object, data frame is an object, list is an object, and functions are these things what we use here: the list, the data frame. All these are inbuilt functions that will help in recognizing the data as the uh, particular object. If you put an array, it will recognize the data as an array. If you put a matrix, it will recognize it as a matrix, and so on. And all of these data information that you're giving after separating it with comma are called arguments. And every function has got arguments, and what are the arguments you can understand by doing this question mark and typing in this function. It will give you what are the arguments that are required to be used within the parenthesis, and what is the meaning or definition of that argument. So, and in the console over here, now suppose I want to access what was the earlier command that I used. I can just press upward button. If I press upward button, I can find out what is the previous command that I wrote, that is viewing what is my list. And then if I again press it, I can keep seeing what is the earlier commands that I do. So when you need to, like, read something, you don't need to keep typing. You can just go here and change it over here, or you can just go here and read it again. That is another thing that is possible. Then yeah, I've told about what is getting working directory, setting working directory, installing packages with RStudio. You can directly install it, or you can use this command install.packages and name of the package to install it in your system. Then loading a package is using this. Now I remember when I'm loading library. I mean, when I'm using library, I have to first load the library BioCro, and only then BioCro, whatever functions are available in BioCro will be available. Now, after loading the library in BioCro, if I want to know what are the objects in BioCro, I can just type BioCro. There is nothing over here that has been run using BioCro. So that is why it is saying that no item called BioCro on the search list, because here we have not run anything using BioCro. Now, if I type in objects alone, I will see whatever is available over here. This one variable has been defined. These are the different variables and different um, things that I had run in this. So whatever is available in this environment over here, I will get it if I just type in the function objects. Then again, if you want to load library, if you want to show where your library is located, if you want to update your packages, install your packages, you can use all these functions. Then again, something, suppose you want to list the same thing, whatever was available over here will come. Objects is giving us an objects over here. You want to list what is all available over here. You can use the list. Now, suppose you want to remove a particular uh, object over here. Then you can type in rm bracket. mm, let's say A. And then again, we are going to list it. You will see this A has been removed from here. So say suppose by mistake I apply use this variable. Now I don't want that to be interfering with any data analysis of mine. So if I want to remove that alone, I will just press RM and whatever is the object that you want to remove. Now I want to remove this find quotient and I'll put find underscore quotient over here, and then I remove it, and then I go list it. I'll see that this find quotient is no longer available in the list or in the environment, which is where I had initially run it. Then suppose you want to remove the whole of the thing. Now you want to start off new, and you don't want all of these df and df2 and matrix and abc and all. Then you will do rm. What was that? Yeah. Rm list is equal to ls, the entire thing, and brackets. And if you enter, you see the environment here. The entire environment is gone. So those are some basic functions that you can do using R. Then again, if you want to see the length of the object, you can just go length. Um, say I run this and I run this line, this line. I want to see the length of mat. What is a it has got 9 data. Basically, number of data available. Now I want to see the length of A. It has got 7 data available. 7 data elements available. So that is what length will do. Dim of an object will give you the dimension of an object. So suppose if I put in dim and the matrix value, I get it is having 3 rows and 3 columns. Now if I put dim A, there is no dimension. It is just a one dimension thing. If I put, that's all we have to know. Then again, class we did mode, how an object is stored. Let's see how mode works. Mode A, it is numeric. Mode mat, it is also numeric. Then this is vector. Cbind is something that will combine all of the column, all of the data as columns. Now, suppose I want to cbind uh, A, comma B, comma C. Number of rows of result is not a multiple of vector length of argument 2. Let's see. Okay, so these are all different rows and columns. So let's try doing this one. Has got 3, 7, 3, 6, 2. True. Okay, so I'm running this and I'm running this, and then I'm binding. Cbind. Cbind A, comma C. And you will see that you get a, data structure where these two vectors are combined into two columns. Now I want to R bind, that is bind the rows into rows A comma C. You will see that I have got this as two rows. Now then yeah, print object, the head of the object, tail of the object. We looked into all of these. You can use this question mark to get the information regarding plots, save history, save dot image. Okay, all of these I think we'll look into it in the later classes. So that was, I think that will be for today's class, how to assign variables, what are the different types of data types, data structures, some ways you can manipulate it. There are a lot of ways you can do it. It is beyond our scope to be able to cover each and every function that can be used, but you can do any amount of manipulation with the data types over here. You can create new columns, you can create new data frames, you can write new data frames, all sorts of stuff like that. So tomorrow I'll just give some, not tomorrow, in the next class, I'll give some small exercises which you can do using R, and how to read data, how to write. Now, we are not always having to create data. We might have to maximum create a column or create a new row. But what we want to do is analyze data. And in order to do that, we want to read some existing data. So how do we read that? How do we write some data that is we have got obtained into some Excel file or a CSV file? All of these I'll do in the next class. So that will be for today. If anybody were getting any errors or need help with anything, you can ask now or you're free to leave the session. Thank you for attending today's session. Hope it was useful. I will be sharing this with you guys. Thank you all.